Welcome to Getting Started with Spark and ML. Mute button got the best of us. The slides are online right now. You can grab the slides at robrich.org. Let's head there. Here at robrich.org, we can click on presentations at the top, and here's Getting Started with Spark and ML. The slides and the presentation and the code are available online right now. You can grab them at GitHub. So while we're here at robrich.org, I'll click on About Me, and here's the content that describes some of the things I've done recently. I'm a Microsoft MVP, a friend of Redgate, a single store developer evangelist. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building free software for them Friday after work. Sunday afternoon, we deliver that completed software back to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp here with the conference or wherever you're connecting from, grab me on Twitter or by email, and let's get philanthropy installed in your neighborhood as well. Some of the other things that I've done, SQL source control basics, mine is chapter 8. And I replied to a .NET Rocks podcast episode. They read my comment on the air and they sent me a mug. Woohoo! So there we go. Let's dig into getting started with Spark and ML. We're going to learn about Spark and machine learning. We talked about this guy. Now let me pop you into this app. This is step 6 in the code that we saw, and we're going to go grab a connection to a database. We're going to load a machine model. We will grab some feature content and create a linear regression model. We'll load that model into place. We'll use that model to predict some data, and ultimately we'll write that data back out into the database. Now this is really cool. There's a lot going on here, and this is what we're going to build up to as we get through the course of today. This application is able to predict values and write it back to our database, keeping track of all of the content that we built as we moved along. So yeah, that was a mouthful. But let's dig into each of those pieces and see how we can get from here to there. We're going to look at the tools that we use for machine learning. We're going to look at an export transform load or an ETL process. We'll build a machine learning model, and we'll operationalize that machine learning model so that we can use these predictions in our business or for fun and profit. Let's dig in. The tools. Now, these aren't the only tools that we can use as we look at machine learning, but these are tools that are quite popular. So let's start here, and then as we need to, we can definitely expand out into more. We'll start with Spark. Spark is a great system for doing batch data processing. It's an engine built on top of Hadoop. Now, the cool part about Spark is that we can get these batches as big or as small as we need to, and parallelize that to be able to get really fast ingestion across all of our content. We'll use Spark because of that really elegant mechanism of communicating between systems. Jupyter. Jupyter is a really interactive, REPL for Python. Jupyter was originally named for Julia, Python, and R, but you can now use notebooks in .NET, PowerShell, SQL. Jupyter is a great place to host these interactive REPL, read, evaluate, print loops for interesting things. We'll use it with Python today. And ultimately then Python. Now there's lots of languages that we can use for machine learning. Python just happens to be the favorite among data scientists. If you have a different language and you prefer to do machine learning in your language, then I'm sure there's a mechanism to plug that into Jupyter and machine learning as well. But there may be a little bit of a learning curve. If you like C# or if you like Java or JavaScript, TensorFlow.js is really cool. So let's dig in. Our first step is to install Spark in Jupyter. There's a few ways to do this. Now, Spark is designed to be run on Linux systems. So if we're not running on Linux, there's a few extra hurdles. In particular on Windows, we'll need to be able to shim between the way Windows does things and the way Spark assumes things, mostly patching Hadoop. Grab these slides from robrich.org and click through each of these blue links to be able to install on the environment that you'd like. We're going to run in containers today because that's the easiest way to get started. We can just Docker compose up and we'll grab our content in Spark. Now, the cool part about containers is that it's a great way to spin up content really quickly. Pardon me. The downside with using containers is that containers don't often have access to the GPUs, and a lot of machine learning is done using the extra computational power of GPUs. So if you are using the container, understand that you may not have as much performance as you expected. Okay, let's dig in. Now, the first thing that we did as I went into this repo, here is a Docker Compose file, and this Docker Compose file will spin up not only the databases that I need, both SQL Server and Single Store, but also we've got this PySpark notebook. Now, once I've got that spun up, the first thing that we'll grab is this URL, including the token. Now, when I have this token, that allows me to log into Jupyter, and I'm right here. Now, I did jump into the Jupyter folder that gets me access to each of my Jupyter notebooks, but let's start first and create a new Jupyter notebook. I can choose the language. In this case, I'm going to choose Python, and we now have access to this immediate runtime experience. Okay, let's type some code. I want to say foo equals bar and print foo. I'm going to choose to run this, or I can hit the shortcut and I've got bar. I'm going to build a new cell either by pushing the new cell button, or I can hit the keyboard shortcut B. Now these cells can either be code or they can be markdown. So I could say, this is the title, link to here. And then I'll hit that same Control Enter to run that cell. And now here's my HTML. Build a new cell. Now this is an interactive REPL. So not only do I have the content that I built, but I also have state preserved. So if I say print foo, then I still have that value. Or let me come in and build that again, and I'll say foo equals baz, and I'll run that. And now I'll rerun this cell, and that value is changed. This is a really, really elegant way to start to experiment with applications and to experiment with data. So what's really fun is we can dig in and start to do our experiments and just figure out the data that we need to do it, explore our data. Okay, so our good hello world is to grab a hello world is a mechanism that allows us to calculate pi. So in our Jupyter notebook, and this is step 1 in our GitHub repo, is Spark startup. Now the cool thing is we can just import PySpark and start reaching into Spark. This cell is running and we've got Spark spinning up. Okay, now let's show our version of Spark. In this case, we're using 245. Let's go parallelize this. We're going to ask for a range of 1,000 numbers, and we're going to take 5 sample numbers out of that list. Here's our 5 sample numbers. If we were to run it again, we would get a different 5 sample numbers. Now let's calculate pi. Now, this is a good hello world to get started with Spark, where we just get a feel for how Spark works. 3.1548. Well, that's not all that precise. If we add more digits, then we can get a more precise number, but of course it will take longer. So let's add some more digits, and 3.14. Oh, yeah, that's pretty close. That's cool. Now, if we need to, we can shut down our Spark instance, but in this case, we'll just leave it running. That got Spark started here in Jupyter, and we're able to do some great Hello World experiences. Let's dig in now to step 2. With step 2, we're going to start to explore data frames. Now here, we're going to do a little bit differently. Last time we just said, I want to instantiate Spark, and we gave it a connection. Now, what I like about this is find Spark will actually go try to find a running Spark cluster across the network. Now, depending on the way that you've set up Spark, that may be great. You may just be able to auto-discover it, but you may also need to specify specific connection details. So you can specify Spark context like this, or you can specify where the server is, or you can go dig into various configuration details that you need. However you're connecting to your Spark instance, or however your company does your Spark authentication, definitely leverage that mechanism. Once you've got that Spark context, then you create a Spark session over the top of that, and that allows you to interact with Spark. So I'm going to run that, and now I've found Spark, and I've instantiated my context. I'm going to use the pandas library here in Python to be able to read content. Now I could read an Excel file, but in this case, I'm going to choose a CSV file. Now the cool part is all of this data is completely random. Thank you to randomuser.me for providing this data. And this Excel file, also provided here in this repo, is just random data. If you were to hit that API, you would get a different set of random data. So I've got that data, and pandas is a really elegant way to describe it. Now let's do it in Spark instead. I'm going to read that content in Spark. Well, actually, I'm going to create a pipeline that will do the reading. Now, nothing actually gets read into Spark until we have an output for doing it. So in this case, we're reading the CSV, we're telling it that we have a header row, and with that header row, now we can identify all of the fields in our data set. That one's still running. It's still running. Okay, well, let's set that aside. Now we can display our data frame. That will be able to show us all of the fields within our data frame. df.collect. That will actually pull the data through our data frame pipeline. df.show, we can take a look at the first few rows. So here's all of the fields that we've got in our data frame. And as we collect, that will actually pull the data out of the file into the screen. This may take a minute. There we go. So we have all of the rows, and we kind of like the output that we got inside pandas. If I do a df.show, it's a little better, but instead, let's be able to pivot it like this. Let's say, let's go grab the first 10 rows and let's dump it into Panda. Pandas is a great way to visualize or graph data. And so here's those first 10 random rows. Now we built that pipeline by linking the data frame. Let's do some other things. We can select some data. Let's grab only the first 3 columns out of that data. We'll sort by this column and limit it to the first 2 rows. We've created this data frame, but we've not actually done anything yet. We string together these data frames, these set of steps, and then when we're ready, now we'll show the content. That will actually execute the data frame. So now I've got just those 3 columns, just 2 rows, and I've sorted by first name. We can also add new columns. Here's a column that will go grab the length of the first name and show that content. And now if we want to, for example, go to JSON and count the data in the JSON row, we can do that as well. So here, flip it to JSON, count the number of JSON objects, and I would expect to get 2 objects. Now this is a great way to build up these mechanisms. Here in the data frame, we can create new frames, we can modify the query, we can add columns, we can remove columns, sort, and really massage the data here in our data frames to get to really cool things. As you grab this code, you can click through each of these links to get more information about the particular details that we're exploring in this Jupyter notebook. So we've got a feel for Jupyter and Spark, and we started exploring data frames. Data frames are a pipeline, a series of steps. Each data frame is immutable, so it doesn't change. Rather, we create a new data frame that will mutate that data. Now, each of these data frames is in effect a function, a process, and none of the data starts flowing through until we do something with that data. Maybe we'll graph it, maybe we'll send it to another database. This mechanism of data frames allows us to build up this pipeline of transformations from our source data to our destination, maybe a graph or maybe another database. Data frames are a really elegant mechanism to be able to move data, and no data starts moving through this process until our destination is specified and we start to pull data through that pipeline. It makes the pipeline really efficient. So let's do a similar mechanism. Let's do some extract, transform, load mechanisms here with Jupyter and Spark. Here in step 3, we'll fire up this notebook and we can do some ETL. Now, the cool part about doing ETL inside Spark is we just build up these data frames and it's really fast to be able to get content in place. Now we'll start off loading some additional packages. I'm going to load the single store Spark connector and also the SQL Server Spark connector. Now, this one is named MemSQL and this one is named Azure, but those are those pieces. These Spark connectors allow us to do really interesting things like connecting to exotic data stores and really speed our process. Again, we'll go find our Spark context in the way that makes sense for your organization. And now we'll log into SQL Server. Now in this case, we're just using a JDBC connection, but we go specify our server and our database, and we can go pull the data out of this particular table, the line item table. Okay, now that we have our data, we can grab the first 2 rows and show it. And I won't run this in this case, but that allows us to get a preview of how this works. We have our data now in MS SQL data. That's the first data frame in our pipeline. Well, we can also do interesting things like here's a select query where we can start to filter down the data that we just need. And we can also do a select query inside of here as we build up a new data frame. So we'll take our original data frame, we'll select some data, we'll group by data, maybe create an average, and we'll display those columns as well. You can see how data frames is a really elegant mechanism of doing this. Now, which is more efficient, building up another data frame or doing the query? That's where the drivers become really effective. Each of those Spark connectors may allow SQL Push Down. Now, the beauty of SQL Push Down is we can take this Spark code and turn it into a more efficient SQL query. Depending on your Spark connector, you may have the ability to do SQL pushdown so that you're only pulling those few details out of your database and not pulling the entire table and then transforming it inside of Spark. So now let's save our data from SQL Server into single store. Now we need to go read let's start out by trying to read data out of single store using the MemSQL connector. And now we have some MemSQL data. Now that we understand how to connect to it, instead of doing a spark.read, let's do a spark.write. But in this case, we're going to go grab that MS SQL data, our SQL Server data, and we're going to write it out to single store. Now we'll specify all of the details that we need. In this case, we can choose to send it to a particular table. We can choose to append or overwrite it. We can choose to recreate that table. And with the power of SQL Pushdown, we can use that to go grab only the bare minimum that we need from SQL Server and be able to write it in parallel off to single store. That is really cool to be able to pull data out of one database and push it into another. And this process is really efficient and really fast. So we saw the process of doing ETL. Now, the cool part is that Spark is amazing for doing that export, transform, and load process. And if all that you get from this talk is how easy it is to use Spark to do ETL, then that's perfect. That is a great milestone. Spark is a wonderful mechanism for getting data out of one system and putting it into another. Let's level up though, and let's look at machine learning. Now, machine learning is definitely a large topic, so let's disambiguate it a little bit. Here's machine learning, this middle one. Now, as machine learning is actually a subset of artificial intelligence. Artificial intelligence kind of means, well, everything that we don't understand. At one point, robotics was artificial intelligence. Artificial intelligence now is broken up into little pieces as we start to understand them, and machine learning is one of those pieces. Deep learning is a subset of machine learning where we combine different machine learning algorithms together to increase the abilities of our machine learning models. Maybe we take an image recognition system together with an audio recognition system, together with a robotic steering system, and we turn that into an autonomous car. One machine learning model, for example, an image recognition system, may not be sufficient, but combining it together with lots of different processes, together with a lot of business rules around how to plan on a road, and we could build a machine learning model that could drive a car. That's what deep learning does, is combine those machine learning models together. Now there is this piece out here, data visualization. The cool part about data visualization is that it isn't part of this machine learning. When some people talk about, I need a machine learning model to do this, what they really mean is they need to be able to visualize the data. If you can find a creative mechanism to visualize the data outside of changing the data, then that might be a really fast solution to the goal. Data visualization is out here. We have artificial intelligence, a subset of that is machine learning, and a subset of that is deep learning. Artificial intelligence and machine learning are different. Everyone that says AI/ML, they probably don't understand either. It's fingernails on the chalkboard to me when I hear AI/ML because, well, artificial intelligence and machine learning are very different. I hope you'll join me in finding that these are different and in exploring ways to make sure that they are kept separate. Artificial intelligence, machine learning, and deep learning are also very different from data visualization. Sometimes the answer is simply to visualize the data, to create a dashboard. If you can create a dashboard that is able to visualize this data, then maybe you don't need a machine learning model at all. Well, let's double click into machine learning. What is that? Well, with our normal applications that we've built for decades, we have inputs, we have some code, and we yield answers. Now we'll craft this code to be able to take these input variables and to yield these answers. That's really awesome. A lot of software that we've built today works exactly this way. We'll type in data, we'll run that through code, and we'll yield some answers that we'll use to make business decisions. By comparison, machine learning works very, very differently. We take our inputs and our answers for known solutions, and we hand it to this process, this training process, that will yield code. We're not writing code. Our machine is writing the code. It's inferring the values, the mechanisms to get from inputs to answers. Now we'll take that code and we'll give it new inputs and we'll yield predictions. Now the beauty here is that nobody wrote this code. The machine inferred the relationship between the inputs and the outputs and built the code itself. On the other hand, what we're yielding is different results. We have predictions. Before we had answers, now we have predictions. They're different. The machine is guessing based on relationships between the inputs and the answers that we gave it, what this new input might yield. We're not going to get a perfect answer. We're going to get a pretty good guess. Probably we need a person to go validate those answers if those answers are critical. Predictions are not answers. Predictions are good guesses, and they may help us get closer to answers, but predictions are not answers. Predictions are not answers. So let's imagine that we have a machine learning model that is able to tell the difference between, for example, US-based tanks and Russian-based tanks. Now, the United States built such a model, and they fed it lots of pictures of tanks, and they built this model. Well, it wasn't very good at predicting what kind of tank it was. There were all the pictures for American tanks were taken during the day, and all the pictures of the Russian tanks were taken at night. So what the machine learning model decided was that if it's daytime, it's a US tank, and if it's nighttime, it's a Russian tank. Well, what if we strapped weapons to that algorithm? Now, any US mission done at night would fail. Predictions are not answers. Machine learning will extrapolate from existing data to yield these predictions. And so because of that, any bias that we have in our data will also be yielded in our model. Amazon built a mechanism where they were trying to pre-filter resumes so that they could get candidates that were ideal and didn't have to do that big filtering process. They built a machine learning model to be able to filter resumes. Well, at the time, Amazon wasn't very good at hiring a diverse workforce. And the machine learning model had noticed that most of the employees hired were male. So the machine learning model rejected every female candidate. That's definitely not what we want. In this case, the biases were exaggerated by the machine learning model. The machine learning model is only trying to find the correlations. If there is any bias in the data, there will be bias in the machine learning model. So how about we exclude data like race or gender from our model? Well, one of the things that's interesting in the United States is that a lot of addresses were racially motivated. So if we have zip code in our data, we have an analog for race. So over time, our machine learning model can become racially biased based on the address data. That's really unfortunate. If we have any bias in our data, we will end up with bias in our machine learning model. We need to be very, very careful to exclude any kind of bias and give our machine learning model a rich set of data in all of the various categories where we're trying to aim for our machine learning predictions. But at the end of the day, they are predictions, they're not answers. If there's any bias in your data, the machine learning training process will identify this bias and will amplify and exaggerate this bias. Be very careful of bias in your machine learning data. Machine learning training techniques. Once we've got our mechanism for building this content, we have our inputs and answers, and we want to hand it off to this model. There's two main ways that we can train it. We have supervised learning and unsupervised learning. In supervised learning, we give the algorithm inputs and answers, and we tell the algorithm to identify the trends. By comparison with unsupervised learning, we give it a goal and we tell it to go figure out that goal. Now, we may have a hybrid approach where we start out giving it some inputs and answers, and then over time we start just letting it explore. Or we may start the other way. We may invite the machine to just start exploring, and over time we'll tune the goals to be able to get a more tight answer from our machine learning process. So we may iterate back and forth. Let's double click into supervised learning and take a look at other mechanisms. Inside supervised learning, we have various algorithms. Machines are really good at answering questions in these forms. If we can get our business questions into these forms, then our machine learning models can help us answer that. If we haven't identified what questions we're asking, then the machine learning model really can't help us. Let's take a look at those. Is this a thing? For example, hot dog or not hot dog? In this case, we can get a picture and we can decide if this picture is that thing. Which thing is this? For example, which type of dog is it? Can we break them into categories? Guess the value. So for example, predict what the price might be given market conditions. What's the best way? For example, what's the shortest path through traffic? Each of these are very separate questions, and there are more, but when we can get our questions into these types of questions, then we can start to do it. Let's use data science terms and unpack this a little. Is this a thing? That's binary classification. Is it a yes or a no, a true or a false? Which thing is this? That's a classification or categorization problem. Let's break it into groups. Guess the value. This is a linear regression where we're trying to anticipate the curve that allows us to get from input to answer. What's the best way? That's an optimization problem where we can run through iterations and start to reduce the test space to be able to find optimal answers with the least amount of effort. So those are the mechanisms that we look at to be able to build machine learning models. We need to create unbiased data. We need to feed it into this training process, and that will yield code that we can use to generate predictions. Now, we may need follow-on processes to validate our predictions. We may need people to validate those predictions. The machine learning models will never be 100% precise. As we look at the steps, oh, we get to do a demo. So let's dig into Jupyter and let's look at using machine learning. Now, Spark is really good at being able to pull data out of data stores really quickly, and we can feed that into machine learning models. So here's our Jupyter notebook. I'm going to start by grabbing those connectors, both the single store, in this case, the single store connector, and then I'm going to go grab the ML Flow package that allows me to do some machine learning inside of Spark. Now I'm going to load this. Oh, am I on? Ah, I did. I launched the wrong one. Let's go build the model before we use the model here in step 4. Okay, here in step 4, I'm going to go grab the single store Spark connector, and I'm going to go connect to my Spark instance. I'm going to read all of the data that I want to do, and in this case, I'm going to limit it to 1 million rows. Now, my goal is to take each of these 5 columns and to be able to predict the extended price. So I'm going to create all of these and assemble it into a vector, a mechanism that the machine learning algorithm can use to be able to identify each of the pieces. Once I've got that vector in this data frame, I will hand that into this linear regression algorithm. Now, this PySpark linear regression algorithm will take those features and start to predict the extended price. I'm going to start off and I'm going to split my data into 2 sets. Now, I may choose 80-20. I may choose, in this case, I did 70-30. I want to break it into 2 sets where I have a training set and a testing set. The training set I will use with inputs and answers to be able to get my machine learning model to build what we need. And then I'll use my test data set to be able to validate if that machine learning model is performing correctly. Now, the algorithm fit will take a good long time. So as you run this, here's the time mechanism so that it can measure how long that takes. And once I've trained my model, now I'm going to evaluate it. I'm going to take that test data set. It will run that through the algorithm and give it a score. Now, the R-squared score is roughly like the score of 100%, but R-squared is definitely much more complex than that. It's the area under the curve. But if I get a model that is 80s, 90s, that's pretty good. If I get a model that's 99 or 100%, I may have an overfit model, and I may need to go look at my data more carefully. So once I've got a model that I like, I'm going to save that Spark model, and now let's take it out for a spin. I'm going to transform that test data set and just take a look at it and see if I've got data that I expect. Now I've got a machine learning model. I've got a machine learning model, and I saved it into this Spark model folder. here's that. Nope, the Spark model isn't in the data store, but I do have that data loaded. And so here's that Spark model. And yeah, it gets kind of weird. Okay, so I've got that Spark model. Now let's use it. Now, the majority of the mechanism, the compute time involved in the Spark model was in that training mechanism. So to train the data takes a long time, but to use it is relatively straightforward. Let's dig into this Spark, this Jupyter notebook, and take a look at how we can use it. I'm going to hook up the Spark connector to my single store data store and go find my MLflow Spark content. I'll load that model into place. And now I'm going to go grab some data from single store. Now, in particular, I'm going to go look for all of the data where the prediction is null. Everything that I haven't run yet. Now that may be 1 row, it may be 100 rows, it may be 1,000,000 rows, it may be no rows. Once I've got that data in the data frame, I'm going to build up that vector again. Now, given that vector, we now can run that through the linear regression algorithm. In this case, we're not training or testing, we're actually using the model to transform the data. Now with that prediction, here's a new frame in my data frame. I'm going to drop the features column. That wasn't part of my data store, but now I have data that has that prediction column set, and I'm going to write that back to single store. Now the beauty here is that I was able to pull all the rows that I hadn't predicted, run that through my machine learning algorithm, and be able to dump that content back into the data. And now I've got that prediction column filled. Perfect. So I want to do this, but I really don't want to have to load up Jupyter and click next on each cell to be able to run this process. I'd really like to maybe run it through Apache Airflow or cron tab. I just want to run it. Well, the beauty here is that we can take that each of the Python steps that we did there and just build a Python file. So here's use the model.py. It's just a regular Python file. And so we'll do each of those steps. Let's go grab the connector. Let's grab MLflow Spark. We'll grab our data where the prediction is null. We will create the vector and load the model, transform the data, and ultimately save those results back to the database. The beauty here is because we're looking for all of the things where the prediction is null and ultimately writing the prediction, once we've done this, each of those rows is done. We're only going to grab new rows. So we could run this once a minute, once an hour, however often we need to be able to update the rest of our data. Now, this was really fun. We got to dig in and build out a machine learning model using Spark. Let's review the steps that we did to get here. Now, we didn't do all of these steps, but here's the steps that we'll use to build out a machine learning model. First, clean your data. We talked about how bias in our data can yield bad models, and so there may be a bit of removing bias. We may also need to remove outlier data or compensate for null values. Once we've cleaned our data, we'll select input and answer parameters. We'll separate our data into training and validation data sets, and then ultimately pass that training data into our model training algorithm. Now, there may be some guessing about which columns we need to be able to use, which algorithms may make sense, and so we'll probably iterate a couple of times until we get a model that we like. We'll score that model with the validation data set. Once we've scored that model, we can get a feel for if that works. Now, if we didn't choose a good algorithm, or maybe our data set was biased, or we chose the wrong columns, we might iterate through here quite a lot until we get a model that we like. Once we've got a model, we can set that in place in our business. Now, ultimately, it's a model that creates predictions, not answers. And the predictions are only as good as the data that we passed in. So maybe as our business needs evolve, maybe as our data set grows, we might choose to learn from that data and repeat this training process. So we'll probably create a loop that will loop us through this process again. As we learn what algorithms work, as we learn what data sets are valuable, we'll retrain our model and publish a new model. And ultimately, if we get a model as we score it that doesn't score as well, or if it isn't as effective in our business processes, we may back up and do a different process as well. Ultimately, we were able to use Jupyter, Spark, and machine learning to be able to create really, really powerful solutions here. Now, machine learning will exaggerate your bias. It is only good at creating guesses, but it is a great mechanism for being able to create some additional value that may be able to sort through data faster. As we get better at guessing, we can build machine learning models that will better facilitate us. We looked at the steps in supervised learning, and we looked at the tools involved. Ultimately, I hope you'll join me in saying that you don't need a PhD in data science to be able to do machine learning. It is quite approachable. This was a lot of fun to dig through machine learning and Spark, and I hope you grabbed value from this. Grab the code and the slides at robrich.org. If you're watching this video later, hit me up on Twitter at rob_rich, and let's dig into the questions that you have. For those people who are live here at AI Day, what are your thoughts and questions?